Hi, in this video I'm going to cover insertion sort algorithm to sort a list, array or any other thing. To add furthermore, we'll take a detailed look at how the insertion sort works. We'll look at the big O analysis of the running time of insertion sort, and then I will show you how to code an insertion sort algorithm in Python or insertion sort program in Python. So let's start by understanding how the insertion sort works. So suppose we have a list with numbers 7, 8, 5, 4, 9, 2 in this form. So the first step is that we consider that the first item is already sorted. So we take the first element as base and then compare it with the next item. Like we say in our case that the 7 is already sorted, and then we will compare the 8 with 7. And if the 7 is less than 8, we leave it as is. And if it's not, we switch the position. In our case, we leave it as is because 7 is less than 8, and then we'll move on to the next one, which is 5. So we'll compare the 5 with 8, and as it's less than 8, we'll switch the position. So the new list would be 7, 5, 8, 4, 9, 2. We'll compare the 5 with 7 again, and it's less, so we'll switch the places again, and the new list would be 5, 7, 8, and so on and so forth. Now that 5, 7, 8 is sorted, we'll start from the 4 and check if the 4 is less than 8, which is, and in that case we'll switch the position and check the 4 again by comparing it with 7, and it's less, we'll switch again and check the 4 again with 5. It's less, and we'll switch the same way. Now 4, 7, 8 is sorted, so we'll start with 9, and 9 is not less than 8, we leave it as is and then move forward to 2. And as it's less than every element in the list, so we will move it to the start of the list by comparing it with each element at the left, and this is basically insertion sort. So insertion sort is an algorithm that sorts a list by comparing the current element with the previous element. If that's less, it will switch the position. If it's not less, it will do nothing. So as you have seen from the process, insertion sort is not particularly fast sorting algorithm because it uses nested loops to sort. It's only useful for relatively small data sets, no more than 10,000 items, and it runs in big O of n squared times. So the fun part is, how can we write a Python program for insertion sort? Well, let's get started. So I have opened a new Jupyter notebook. Let's start coding. So the first thing would be to create a function for insertion sort, which will receive a list. Let's name that list A. So inside that function, we will be having a for loop having a temporary variable I, and it will start, let's give it a range. It will start from 1 and it will go till the length of A. Now, as I have said in the theory part of the insertion sort, this algorithm uses nested loop for sorting. So for that purpose, we'll create another variable, and we will give it j as a temporary variable because we have already used I. So it will also receive, it will also loop through, and it will be having a range function. And in that range function, we'll start from I minus 1. If you remember, when we were comparing the values, we were comparing the current value with its previous one. So our current value is I, and we will compare it with the previous, which is I minus 1. And it will go till 0 because it will check, it will start from the current element, and it will check the previous one, then the previous one, and then the previous one, and it will go till it goes to the zeroth element, and the step size would be minus 1. And this is our nested loops. Now the only thing is we need to add a condition, and that condition would be if the current element in the list is less than the previous element in the list, which is AI is the current element and AJ is the previous element. So if the current element is less than the previous element, we want to switch. So the switching would be the AI, comma, AJ and equal to AJ, comma, AI. So if this is complicated, no problem. What I'm doing is I'm just saying AI is equal to AJ and AJ is equal to AI, but I'm just doing it in one line. So let me comment these things for you. If you're willing to use these one, you can use these one, but for me, this one would do. Anyway, if it's not greater, that means it's sorted. So in that case, we just want to break the loop, and that's it. That's our sort algorithm. Now let's check it out by giving it list or something like that. So let's run the program. So now everything is okay. I have pressed shift and enter and the function ran perfectly fine. Let's give it a list, and the list should be unsorted. So I have created a list with having elements 5, 9, 1, 2, 4, 8, something silly like that. So the next thing would be to check and call the function. So the first thing I want to do is print the list and then call this sort function and then print the sorted list again. So let's run the program, and you can see at first the list was unsorted, but then we have this sorted list, and we have a little bit of a problem, which is we need to go till -1. And if I press shift and enter and come over here and then run the program again, you can see that our list is perfectly sorted. So this is insertion sort algorithm. Once again, we created a function. We started a for loop in which we started from 1 and we looped through till the length of the list. And after that, we created another loop which is nested in the previous one, and we started as j. At this moment, we were having the current element, but right now we are creating the previous element. Once we create the previous element, we just compare the values of current and previous with a condition. If the condition is true, we switch the values. If it's not true, we don't do anything. We just break the loop, and that's it. Okay, now that we have seen the insertion sort algorithm with a for loop, let's do the same thing with a while loop as well. So the first function was insert. Let's rename this function as insert2, and it will receive a list as the previous one. We'll create the same for loop as is. I will just copy and paste it from the previous one, and inside this, instead of creating another for loop, we'll just create a variable by the name of j, and we'll make it equal to I minus 1. Once we do that, the next thing we will do, we'll create a while loop, and in that loop we'll give it a condition as if the current element is greater than the previous element, which is j plus 1, and j is greater than or equal to 0, and it should be outside these square brackets. If the AI is greater than aj plus 1 and j is greater than or equal to 0, we want to swap. And I just mistakenly pressed shift and enter, but instead what we'll do, we'll do the same thing, the swapping thing right over here, which is, and instead of just j, we'll write j plus 1. And we'll do the same thing right over here as well. So this is pretty much it. The next thing we want to do is just decrement the j by 1. And if I press shift and enter and call this insertion sort 2 in the same manner that we did with the previous one, so that would be insertion 2. And if I run the program, you would see that everything would be the same as it was. So we give it an unsorted list, and it returns a sorted list. Now that we have seen the insertion sort algorithm with for loop as well as with while loop, Now there is a little bit of deficiency in these processes. Like insertion sort is not that much faster algorithm. It takes more time, and the thing we are doing right over here make it more expensive for the memory and the time. So we can just optimize it with a little trick, and that is with the trick of swapping. So let's create the code for the optimized version of insertion sort. So we'll do the same thing. I will just copy and paste the function, and let's rename it insertion sort 3. And inside that, the first thing would be to create a for loop, and in that for loop, and that is the same for loop we created previously. But what we would do is different is we'll create a new variable right over here by the name of temp, and we'll make it equal to the current element, which is AI. And after doing that, we'll create another variable by the name of, and after that, we'll create another for loop having a variable j in it, and that would loop through the same thing as range, and the range would start from I minus 1, the way we did in the first one, and it will go till -2th element, and the step size would be -1. And that's the for loop we want to run with. Now let's create another variable above from this for loop, which would be k, and let's make it 0. And once we run this for loop, we'll assign this k with the value of j. Once we do that, after that we'll create a condition, and in that condition we'll check if the previous element, which is aj, is greater than the temp value or the temp variable, or what the temp variable is having. So we want to do the swap thing. We want to swap it. The aj plus 1 would be equal to aj, and that's it. And if it's not greater, or in other words, if the condition is false, we just want to break the loop. Once the loop is broken, right over here with this indentation, we want to just make the k plus 1 equal to, like the temp value would be equal to the current value. So this is basically the swapping thing. You know, the last one would be sorted as the first one, because it's like, in our case, if you look at right over here, you can see that if you go to the previous example, now the last element would be brought to the first position. So that's pretty much it. Now if we run the same thing, if I press shift and enter, everything is okay. If I come over here and run the insertion sort 3 with the same thing, you would see that we will get the same result. But this process is a little bit more faster than these two. Otherwise, it will work the same way. So once again, if you're willing to do the insertion sort, you will do it with two loops. So you will do it with two loops. That would be nested loops. So the first thing would be to create a function with insertion, with having a name insertion sort. You can literally name it anything, but it's the good thing. You will create the first loop, then you will create the next loop, and you will start the first loop from 1, and it will go till the length of the list. You will create the second loop, and it will start from I minus 1, and it will go till -1, and it will be having the step size of -1. We'll create a condition. If AI is less than aj, we'll swap, otherwise we'll not. And here you can see it works perfectly fine. Now the while loop is the same, and we have this optimized version of the insertion sort algorithm. So this is pretty much it for this video. I hope you did learn something. My main purpose of this video was to show you how the insertion sort algorithm works and how you can implement in Python. So till next time, enjoy hacking, stay cheeky breaky, and peace out.